Welcome to the channel. Mr. G here, and in this video, we're solving equations in one variable. This video is designed for those currently studying Algebra 1 or brushing up on algebra skills. I recommend pausing the video now to find a notebook and something to write with. And we're on in 5, 4, 3, 2, 1. Our learning goal. Given an equation in one variable, isolate the variable. Isolate meaning get the variable by itself. Let's start with a model. Consider the equation 3x plus 7 is equal to 16. I'm going to set up this equation using algebra tiles. Notice, on the left side of our model, we have 3 positive x tiles representing positive 3x and 7 positive unit tiles representing positive 7. On the right side, we have 16 positive unit tiles representing positive 16. Before we can isolate the variable x, we need to isolate the variable term 3x. To do this, we need to subtract 7 or add 7 negative unit tiles. What we do on one side of our equation, we must do on the other side. The positive unit tiles and the negative unit tiles will zero out, leaving 3 positive x tiles, or 3x, on the left side of the equation, and 9 positive unit tiles, or 9, on the right side of the equation. We know that 3 of x is equal to 9, so we will split up both sides of our equation into 3 equal groups, also known as dividing by 3. Looking at each group, we can find out that 1x is equal to 3. Let's try another equation. Consider the equation 4x plus 8 is equal to 6x plus 2. Let's set up our algebra tiles. On the left side of our model, we have 4 positive x tiles representing 4x and 8 positive unit tiles representing positive 8. On the right side, we have 6 positive x tiles representing 6x and 2 positive unit tiles representing positive 2. Notice that we have variable terms on both sides of the equation. We need to make it so that we only have a variable term on one side. To do this, we will add 4 negative x tiles or subtract 4x from both sides of our equation. The positive and negative tiles will zero out, leaving 8 positive unit tiles on the left side and 2 positive x tiles and 2 positive units on the right side, or 8 is equal to 2x plus 2. We need to isolate our variable term before we can isolate our variable. To do this, we will add 2 negative unit tiles to both sides of the equation or subtract 2. The positive and negative tiles will zero out, leaving 6 is equal to 2x. We know that 2 of x is 6, so by splitting both sides of our equation into 2 equal groups, or dividing both sides by 2, we find out that x is equal to 3. Let's review 2 key concepts before we get into the main part of this lesson. First, the distributive property. The distributive property states that some number a times the quantity b plus c is equal to a times b plus a times c. Let's look at an example. Consider the expression 2 times the quantity x plus 7. This means that we have 2 of x and 2 of 7, or 2 times x and 2 times 7. 2 times x is 2x, and 2 times 7 is 14, giving us the expression 2x plus 14. Let's try another one. Consider the expression negative 5 times the quantity x minus 3, meaning that we have negative 5 of x and negative 5 of negative 3. Negative 5 times x is negative 5x, and negative 5 times negative 3 is positive 15, because a negative times a negative is a positive. Next, let's look at like terms. By definition, like terms are terms that have the same variable raised to the same exponent, or they are constant, meaning they have no variable. Let's look at an example. Consider the expression 2x plus 5 minus x minus 18. I have color-coded the like terms here. Notice, we have a positive 2x to the first power and a negative x to the first power, as well as a positive 5 and a negative 18. Let's regroup them. Again, we have a positive 2x to the first power and a negative x to the first power, plus 5 and a negative 18. Combining like terms, 2x and negative x will give us a positive 1x, and positive 5 and negative 18 will give us negative 13, giving us the simplified expression x minus 13. Right, this video is about solving equations in one variable, so let's get into some examples. Consider the equation negative 11 minus 2p is equal to 6p plus 5 times the quantity p plus 3. Before we can move forward with this equation, we need to do something about the parentheses on the right side of our equation. Notice, we have 5 times the quantity p plus 3, meaning we have 5 of p and 5 of 3. In other words, we can distribute 5, giving us 5 times p plus 5 times 3. 5 times p is 5p, and 5 times 3 is 15, giving us 5p plus 15. Copying down the rest of our equation, now we have negative 11 minus 2p is equal to 6p plus 5p plus 15. We have like terms, 6p and 5p, on the right side of our equation. So here, we should combine 6p and 5p, giving us 11p. Now, we have a negative 11 minus 2p is equal to 11p plus 15. Now, we need to make it so that we only have a variable term on one side of our equation. To do this, we'll add 2p to both sides. Negative 2p and positive 2p will zero out, giving us negative 11 on the left side of our equation. 11p and 2p can be combined on the right side of our equation, giving us 13p plus 15. Now that we have a variable term on one side of the equation, we can isolate the variable term 13p, because we need to do this before we can isolate p. To do this, we will subtract 15 from both sides. Negative 11 minus 15 is negative 26. And because positive 15 and negative 15 zero out, we now have negative 26 is equal to 13p. To isolate p, we will divide both sides by 13, giving us p is equal to negative 2, because negative 26 divided by positive 13 divides evenly, and the quotient is negative 2, because a Negative divided by a positive is a negative. Okay, let's look at another example. Consider the equation 2m minus 5 all divided by 3 is equal to 4m minus 3. We really should do something about the denominator 3 on the left side of the equation. To do this, we will multiply both sides by 3. Multiplying the left expression by 3 causes the 3's to multiply out, leaving 2m minus 5. On the right side, we need to distribute the 3 across the expression 4m minus 3, giving us 12m from 3 times 4m, and negative 9 from 3 times negative 3. Next, we will make it so that we only have a variable term on one side of our equation. To do this, we will subtract 2m from both sides. Positive 2m and negative 2m zero out, leaving negative 5 alone on the left side of our equation. 12m minus 2m is 10m, giving us 10m minus 9 on the right side of our equation. Finally, we can isolate the variable term 10m by adding 9 to both sides. Negative 5 plus 9 is positive 4, and the negative 9 and positive 9 on the right side will zero out, leaving 10m. Now we know that 10 of m is 4, so to isolate m, we will divide both sides by 10. Here, we could give the decimal answer 0.4, but because we do not have a context that requires a decimal, we will simplify 4 over 10. 4 and 10 are both even numbers, so we know they have a common factor of 2. So let's divide both the numerator and the denominator by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5, giving us the solution m is equal to 2/5. Right. Now, I'm going to give you two equations to solve on your own. I encourage you to check your solutions using substitution. Pause the video for each problem to try it on your own, then resume playback to reveal the solution. Equation number 1. 4x minus 7 all over 5 is equal to 2x minus 3. Pause the video now to try this on your own. I will reveal the solution in 5, 4, 3, 2, 1. The solution to equation 1 is x is equal to negative 11/3. Now consider equation 2. 8 plus 5 times the quantity 16 plus 9y is equal to 35y. Pause the video to try this one on your own. I will reveal the solution to equation 2 in 5, 4, 3, 2, 1. The solution to equation 2 is y is equal to negative 44/5. How'd you do? Remember, you can check your solutions using substitution. In other words, substituting your value for the variable into the original equation and finding out if it makes the equation true. That wraps up this video lesson. Thank you for watching. Mr. G out.